coming 5-10 minutes, so please allow them.
Fine, sir.
And if any, all the learners, please be alert if any, because ma'am will be teaching you. And in case somebody is waiting to join, then please ask ma'am to allow him or her. Because sometimes what happens, many students remain outside the meeting. So yeah, somehow we have to entertain all. Okay, ma'am, thank you. And
Fine,
meeting
sir.
is over to you, ma'am. Thank you.
Fine, sir. So students, I think my screen is visible to all of you. Please respond so that I know that
Yes.
all can hear me.
Very
Fine.
visible.
Visible,
Fine.
ma'am.
So we are starting here discrete mathematics. Code is MCS212. In discrete mathematics, you are having 5 blocks. First block is about elementary logic and proofs. Second about set theory and languages. Third about counting principles. And fourth about graph theory. Today we will start block 1, elementary logic and proofs, where we will start with unit 1, that is propositional calculus. Thereafter we will proceed in this way. Block by block we will complete. So today we are starting with block 1, elementary logic and proofs. Here we will start with unit 1, that is propositional calculus. Fine. Now the layout is clear, I think. Now today we will start with propositional calculus. First of all, we will see what is a proposition. Any one of you knows about proposition? What is a proposition? We know we have different types of sentences. Like one of the sentences, sky is blue. So we have to identify whether this sentence is a proposition or not. If we know that the value of this sentence is true or false, it means that sentence is proposition. Now, please, anyone can answer that sky is blue is a proposition or not?
Yes, sir. Because
Yes,
true.
sky is blue. So
Blue.
the value is true. So sky is blue is a proposition. Okay, fine. Is it clear? So we can say that proposition are declarative sentences. And the value of these sentences can be true or false. Fine. Let us see few examples. So we can say propositions can be true or false. Fine. Let us see few examples. Suppose we have one sentence like grass is green. So its truth value is true. Yes, grass is green. So we can say grass is green is a sentence which is a type of proposition. Why this is a proposition? Because its value is true. Then we have another statement. 2 plus 5 is equal to 5. Its value is false. Again, as the value is false, we can say that it is also a type of proposition. So the propositions are declarative statements whose values can be true or false. Fine.
Excuse me, ma'am. Excuse me, ma'am. The 3 learners are waiting to be admitted.
Okay,
Please
fine,
see.
sir.
Yes.
Fine, sir.
Yes, ma'am. Are you able to see them?
Yes, sir.
In...
Yes, sir.
Okay.
Sir, I have admitted all 3 of them.
Okay. Okay. Yes.
Fine, sir. Is there anyone else?
No, it's fine, ma'am.
Fine, sir. Is my screen audible?
Yes.
Students?
Yes,
Yes,
madam.
ma'am.
Fine. So we were studying about proposition. Block 1, unit 1. So proposition is any sentence, declarative sentence, whose value can be true or false. Fine. Now we will see examples. Suppose we have one sentence, 5 is a prime number. Fine. Its value is true. So we can say it is declarative sentence and its value is true. So it is also a proposition. Now we have another sentence. 8 is an odd number. Fine. 8 is an odd number. It is false. Okay. So we can say this sentence is declarative and proposition. So any sentence whose truth value is true or false is a proposition. Fine. So we have seen examples of proposition. Let us see another sentence. An egg has protein in it. Fine. What is its true or truth value? True. So it is proposition. So proposition will have two values, either true or false. Any
Ma'am, that's
declarative statement for which
ma'am,
we can have true value or false value, we can say this sentence is a proposition. Fine.
ma'am, screen is not visible.
Okay, fine. I'll restart.
It's okay. Now it's
Fine.
okay. Yeah.
Just wait, I will restart. Is it visible now?
No, ma'am.
Screen is still not visible?
No, ma'am.
It's visible, mom.
Is it
Now
visible?
it's
No, it's
Now
visible.
it's visible.
Yes. Let me restart. See, is it visible? Yes, my screen is visible.
Still no.
Yes.
No. Yes, it is visible.
It is visible now. It is visible now.
Yes, yes.
It was visible from the first time.
Fine, fine, fine. See, now is it visible?
Yes.
All of you can see my screen?
Yes, miss.
Yes,
Okay.
yes, madam.
So this is our unit 1 of discrete mathematics, block 1, elementary logic and proofs. We are studying unit 1, propositional calculus. We have started with proposition. My screen is visible?
Yes, ma'am, it is visible.
Okay.
Yes.
We have started with proposition. So proposition are declarative sentences whose values can be true or false. So we have seen some examples like grass is green. It is true. So it is a proposition. 2 plus 5 is equal to 5. This statement is false. So again, it is a proposition. For being a proposition, the sentence truth value should be either true or false. We can see few more examples. 5 is a prime number. It is declarative sentence and its truth value is true. So it is a proposition. We can see another example. 8 is an odd number. Its truth value is false. It is a declarative sentence. So it is again a proposition. Let us see one more example. An egg has protein in it. Its truth value is true. So it is a proposition. Next. Now you have few examples. One is watch the film. Yes, please tell me whether this is a proposition or not. Watch the film.
No, ma'am, it's
Second
not proposition.
Yes.
It's
Is
not
it a
proposition.
proposition?
No.
No. How wonderful. This is exclamatory sentence. So this is not a proposition. Then third is what did you say? This is question. So question is never a proposition. Was the
Declarative.
film is order. So it is not a proposition. How wonderful. You are saying an exclamation mark. No. This is exclamatory. So this is not the proposition. And third one is what did you say? This is question. So again, this is not a proposition. Fine. So these are the results along with the reasons. Fine. Now let us see another example. X plus y is greater than 0. How many of you say that it is a proposition? Any example? Yes.
Yes,
X
ma'am, it
plus
can
y
be.
is greater than 0. Is this a proposition?
Yes, ma'am, it can be.
It it can have multiple values. We have, suppose we don't write x is equal to 1 and y is equal to -2. Then in that case, it is a proposition. Because we will put any values 1, 2, 3, 4, whatever values we will put, every value will be greater than 0. So in that case, x plus y greater than 0 will be a proposition. But if we will put x is equal to 1 and y is equal to -2, just see, x plus y greater than 0, x value 1 and y's value is -2. So minus, it is coming out, -1 is greater than equal to 0. Again, it is false as the value is coming false. So in this case, it is a proposition because value is coming false. If value comes true or if value comes false, the statement is a proposition. Fine. Yes. We always denote propositions with a small case letter, either P or Q or R or S or T. Like P. Fine. Sky is blue. So sky is blue is a proposition which is represented by small letter P. Fine. Like we are having ice is always cold. This is a proposition and we have represented it with a small letter P. Fine. Now we can combine the propositions. We can combine proposition. One proposition is P and another proposition is Q. We can combine P and Q. And we can write P or Q. P or Q. P or Q. See here, P is a proposition, Q is a proposition, and when we have combined P or Q, so this is what? OR. And OR is known as disjunction. OR is known as disjunction. So this is one of the logical connectives through which we can combine the proposition. Let us see example.
Excuse me, ma'am.
Yes.
The slide is stuck on slide number 11 for me.
Yes, please, pardon.
The slide number 11 is still showing on. No other slide is showing for me. Is it
See, all
stuck
slides
or?
are visible. See here.
Yeah, we have also that
Now
problem.
you can see
No.
slide.
No, ma'am, just it's stuck on
Yes,
slide.
No,
madam,
ma'am.
you see just one
Slide-
slide.
Okay, okay.
Still on
Slide
the same page.
11.
Fine, I can restart. Fine, just wait. I will restart.
Now it is showing.
Now is it visible?
Yes, ma'am. Now
Yes,
it's
now
visible.
it's visible.
Yes,
Okay.
it is
Okay,
visible.
fine. See, now is it visible? Class?
No, ma'am.
See, is it visible?
Now it's visible.
Yes, class?
Yes, ma'am.
Yes, ma'am. Yes, it is visible
Okay.
now.
Okay. So we are doing logical connectives. Have you understood what is proposition?
Yes.
Proposition is any declarative sentence for which we can assign true or a false value. So how can we combine this proposition with the help of logical connectives? And one of the logical connective is disjunction. Like we have proposition R and S. How can we combine R or S? Or it is denoted by R or S. Fine. Let us see few examples. We have one proposition, Amit has written a book. And we have another proposition, Diya has written a book. So Amit has written a book is represented by P, whereas Diya has written a book is represented by Q. So disjunction of P and Q is represented as P or Q. That is, Amit has written a book or Diya has written a book. See here, or, and this is same. This or is same as this. Fine. And how we can form a truth table for this disjunction? We have one variable P. We have another variable Q. P represents, suppose, our first proposition. Q represents our second proposition. Now we have to find P or Q, which is represented by P or Q, or we can say P disjunction Q. In form of truth table, how you are going to design the truth table? Fine. To design the truth table, what you have to do? You have to write P, Q, P or Q. Fine. If you have two variables in table, you will be having 4 rows, like truth value for Q, truth,
Ma'am,
false.
we are still on the same page.
Yes,
Please, next page. We want to see the
yes,
table. We not see
yes,
the table.
yes,
ma'am.
class, yes.
Ma'am, table
Yes,
is not
madam.
visible. If you
See only the
just
same
change the
page.
sheet.
Now is it visible?
Not it.
No.
Okay, I'll show. Now is it visible?
Yes.
Yes.
Okay.
Yes. Yes, madam.
So we have variable P and variable Q. For Q, write true, false, true, false. Next, second column is for P, true, true, false, false. So in Q, we are having true, false, true, false. For P, true, true, false, false. So we are having all possible combinations of P and Q. Now see what is the result of disjunction. P or Q. So true, true, result is true. True, false, result is true. False, true, result is true. And only for false, false, and only for false, false, result is false. For disjunction, and fine. For disjunction, the result is false only if both the variables are having false truth values. Fine. You can see my slide, class.
Yes, ma'am.
This table is
Yes.
visible to
Just we
all of
see the
you.
table.
Yes, yes.
Yes, we see the table.
Ma'am,
This table is clear?
can you explain the third row? False true is also the result is
Yes.
true. Why?
You have to remember this table. Fine. No, I will show it. Yes. P, Q, fine. P or Q. This is disjunction operation. Disjunction. Fine. See here. In this case, false is only the result where both the values are false. Fine. Otherwise, result is true. So how you will form the table? You are having two variables. You have having two variables. One is P and another is Q. Now how to draw this table? True, false, true, false. Again, true, true, false, false. In case of disjunction, if both the variables are true, result is true. Fine. One is true, one is false, result is true. One is false, one is true, result is true. And if both are false, both are false, result is false, as you can see here. Fine. Both are false, result is false. So this is disjunction operation. Is it clear? And suppose in one case you are having three variables. So how will you design this table? How are you going to design this table? True, false, true, false. Fine. True, false, and true, false. In this way. where you were having 2 variables, 2 की power 2, 4 rows. You were having 3 variables, it means 2 की power 3, 8 rows. So here true, true, false, false, true, true, false, false, and again 4 times true and 4 times false. In this way, you have to create the table. Fine. Is it clear, class? Is it clear?
Yes, ma'am, clear.
Yes, it's clear.
So this was disjunction operation. Fine. Now, see, truth value of disjunction 3 plus 5 is equal to 2. This is Q. This is Q. 3 plus 5 is equal to 2. It is represented as Q. Another one is the earth is flat. It is represented by P. And you have to perform disjunction between P and Q and find the value. Tell me, earth is flat. It will be true or false? Yes,
False.
class, earth is flat. It will be true or false?
False, because both
False.
of them is
Yes,
false.
it will be false.
False.
And 3 plus 5 is equal to true. It will be true or false?
False.
False.
It will be false. When both are false, when P is false, Q is false, what will be the result?
False.
False.
All is
Fine.
also false.
So these type of examples come in your exam where it is asked that if the value of two propositions are given, then find disjunction between them. One of the proposition is represented by P and another proposition is represented by Q, and you have to find P or Q. Yeah, P disjunction Q. Fine. And this table is going to be very useful and you should know how to draw this table. Fine. Fine, class.
Yes,
Yes,
miss.
ma'am.
So suppose you are having only one variable. How will you draw the table? You are having only P. Okay. So you will make table like true and false. You are having two variables. Fine. Your variables are P and Q. So how will you form a table? P, Q, true, false. Okay. Like in this way, true, false, true, true, false, false. Now you are having three variables, P, Q, and R. How will you form the table? P, Q, R. How are you going to form the table? For three variables, 2 की power 3.
Eight.
You will be having 8 rows. 8 rows. Fine. So how will you design? True, false, true, false, true, false, true, false. Again, true, true, false, false, true, true, false, false, true, and false. Fine. In this way, for different number of variables, you can design the table. Fine. Let us see example. Now we have another case of disjunction, which is known as exclusive disjunction, and it is represented by symbol like this. Okay. And here the truth table will differ. In truth table, you will be having truth values only if one of the statement is true. But when both the statements are true or both the statement are false, you will be having false result. Fine. Keep it in mind that you will be having true values only if one of the proposition is true. Let us see in this case, this one is true. In this case, this one is true. That is why in both the cases, you are having true values. Fine. Is it clear? Class, is it clear?
Yes, ma'am.
ma'am.
Yes, madam.
Okay. So we have done this example. Now, conjunction. Conjunction is also one of the connective.
Why?
Yes.
Okay, ma'am, I have one question. Why true in true is the value is false? The result is
Because
false.
when we create its circuit diagram, the results come out to be like this. In digital logic, we create circuits for these things, and in circuit we design p as 0. Suppose the truth value of t as 1 and truth value of false as 0, 0 bit and 1 bit. And when we draw the digital circuit, the output comes like that. For 1 we represent true value, and for 0 we represent false value. Fine. Actual output that comes out of the digital circuit is like this. Fine.
So as per that, ma'am, there will be false. False should be false, not true.
Yes.
I mean that if there is in truth table false and false, so the result should be false, because as per Boolean algebra, we can say as binary circuits, so false, false, 0, 0 will be 0, not
Yes.
true. As we
False,
said,
false is false.
false.
In different cases, result will differ. In case of conjunction, disjunction, negation, you have different types of connectives, and the result will vary depending upon the type of connective used. Fine. Let us see in case of conjunction. Conjunction is a connective where you represent it as P and Q. Okay. This is the conjunction of statements P and Q, and A and D, P and Q. See, the output will be different. Here, see, in case of P and Q, true, true is true. Fine. See here, true, true is true. Whereas true, false is false. False, true is false. And false, false is false. In case of conjunction, conjunction means and. Fine. This is the case of conjunction, anding. In anding, if any one is false, result will be false. Result will be false. See here, this is one of the example. Obtain the truth value of conjunction. Fine. And conjunction के लिए you have two statements. One is P and another one is Q. Another one is Q. This one is P and this one is Q. See, find the value of P conjunction Q, यानी कि P and Q. When we will see 2 divided by 5 is equal to 1, is it true?
False.
Is 2 divided by 5 equal to 1?
No.
No, it's
No,
false.
it's false.
Fine. So P's value is false. Now Padma is in Bangalore. We don't
It
want
may be true.
value of Q because we know as one of the value is P that is false, so the result will be false. Because false true is false. False false is false. Fine.
In the case of
Is it
conjunction,
clear? So if we know any one value, like we know the value of any of the statement, this is false, so result will obviously be false. Fine. Now comes the negation. Negation is represented like this. Negation of Q, negation of T. Always represent proposition with the small letter. Negation of R. Fine. Not P. It is known as not P. Yeah, not R. Yeah, not G. Not T. Not N. Like this. Fine. It is the negation of sentence. It is a negation of proposition. For example, if we say P is a proposition which state that Amit is in school, so what not P will represent? Amit is not in the school. This is negation. And how can you represent negation? P, not P. If P is true, not P is false. If P is false, not P is true. Fine. In this way, you can represent negation. This is what? This is negation of P. Fine. And now we were studying what we were studying. We were studying connectives. Connectives again, there are different types of connectives. Like one we can see here is your conditional connective. If P, then Q. And how it is represented? It is represented as P implies Q. You can read it like P implies Q. Or few other examples. Fine. Few other examples could be like L implies M. Like N implies R. Fine. Now we will see the cases. We'll understand how it works, how we can read it. If P, then Q. P implies Q. How we can read it? If P, then Q. Or P implies Q. Or P is sufficient for Q. Or P only if Q. These are all possible ways to read this. If P, then Q. Or P implies Q. Or P is sufficient for Q. Or P only if Q. Now let us see how implication works. P implies Q. It is conditional statement, or we can say it is conditional proposition, or we can say it is conditional proposition. Fine. Now let us see the truth table. My screen is visible to all of you?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
Now see the truth table for implication. Implication means ye. So we have P, we have Q. And let us see the truth table for implication. Fine. Truth table for implication. Fine. True, false, false. Okay. And if we want to find the opposite, yani converse of P implies Q, so it is P implies Q. Converse is Q implies P. Fine. And how you read it? You read it as P is necessary for Q. P is necessary for Q. Fine. You can see this table in my screen.
Yes.
Yes, ma'am.
Okay. We are having P, we are having Q. Fine. Now P implies Q. Form your table. Just design your own table. What you will do? You will write P, you will write Q. Fine. True, false, true, false. Then true, true, false, false. Make your own table, please. In this way, you start creating your table. Then
It's not visible for me.
it is not visible. For others, is it visible?
It's visible.
Yes,
Yes,
it is visible.
Is it visible?
So
Huh?
it's
It is visible. It's visible.
Just check. Just check. Okay. Then P implies Q. P implies Q. See, true and false. The result is false. Fine. Then find Q implies P. So from here, see, Q implies P. Just try to find out on your own. Yes, class, try to find out on your own. Just create your table. Try it. Create your table. Are you trying, class? Class, are you trying on your own?
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am. Yes, ma'am.
Yes. First, just draw two columns, P and Q, and put truth values. What you have to find? You find P implies Q. Create a column for P implies Q and find the values. Yes. P, Q. True, false, true, false. Have you started?
Yes.
Then true, true, false, false. Now find P implies Q. P implies Q.
True first.
Fine. It will be false for the case where P is true and Q is false. True, false combination. So here it will be false. For other cases, it will be true. Now
Yes.
find Q implies P. Just reverse. Q implies P. So this is what true, true, false, true,
False. True.
true, false, true, false, true, false. For true, false, you will be having result as false. All other cases will be true. Fine. Is it clear? Is
Yes,
it
sir.
clear,
Yes, ma'am.
class? Now you have this P implies Q. Now you have Q implies P. Now you have Q implies P. You have P implies Q. Is it clear?
Yes.
And you want bidirectional implication, the result of P bidirectional Q. Are you able to view this clearly? Yes, class?
Yes. Yes, ma'am.
Yes, ma'am.
Okay. So true, true. Result
True.
is true.
True.
For false, true, result is false. For true, false, result is false.
False.
Fine. Is it clear? Is it clear?
Yes, ma'am.
For
Yes,
true,
ma'am.
true, result
Yes,
is
ma'am.
True.
for any one false. For any one false, result is
False.
false. So in this way, you can compute for any logical connectivity. So here we are having example P implies Q and Q implies P. Fine. P implies, and it is written as bidirectional of P and Q, as you have seen in the previous example. Bidirectional of P and Q. What it means? It means P implies Q and Q implies P. P implies Q and Q implies P. Fine. P implies Q and Q implies P. Okay. How it is read? It is read as P implies and is implied by Q, or bidirectional of P and Q, or P if and only Q, or if double I double F if, or P is necessary and sufficient for Q. So it is P bidirectional Q. Fine. Now you have to question is you have to find the truth table or the truth value of two-way implication. That is P implies Q and Q implies P. Or we can say bidirectional of P and Q. What is this? How will you go? You will firstly find P implies Q and then you will find Q implies P. Ending बीच में क्या है? What you are having? And in this way you are going to find bidirectional of P and Q. In this way, firstly you will start creating truth table. You will assign values to the variables. For Q, true, false, true, false. For P, true, true, false, false. You will try to find P implies Q. Okay, P implies Q. It will be false for a combination of true, false, false. This is your P implies Q. Then you will try to find Q implies P. Q implies P. तो ट्रू ट्रू ठीक है, फॉल्स ट्रू ठीक है, ट्रू फॉल्स फॉर this combination true false, you will be having value as false. Now you have filled P implies Q, Q implies P. Now you can find bidirectional, that is P implies Q and Q implies P. You have to do the ending of P implies Q and Q implies P. That is bidirectional of P and Q. For this, see, true, true, value is true, false, true, false. For single false, result is false, true, false, false, and for true, true, you are having value true. So false value are in case where either one of the value is false. In those cases, you are having result as false. My screen is visible to all of you, class?
Yes.
Yes, ma'am.
So here we are having one question for you. Write down the truth table of P implies Q and not R, bidirectional R. ठीक है, डन. अब आपको क्या करना है, इसको सॉल्व करना है. तो go back and see what are these symbols and how they are computed. Just identify the symbols, just revision, and then you have to work on finding the truth value of the given statements. See disjunction, write in your copies. Fine. Disjunction is or disjunction is your or. See the symbol of disjunction.
Yes.
Okay, this is your disjunction. Fine. Or. Now this is disjunction. Now exclusive disjunction. See the symbol, exclusive disjunction. See the symbol here. Fine. This is what? This is your exclusive. This is what? This is your exclusive disjunction. This is your exclusive disjunction. See the symbol here. Here the result is true. Result is true only when one of the arguments is true. Fine. For true false, result is true. For false true, result is true. Then going down, exclusive disjunction ho gaya. Then now coming to conjunction. Conjunction is and. See the symbol here. See the symbol and. Fine. And result is true when both are true. When both are true, result is true. Fine. Otherwise, result is false. So this is the case of disjunction. Sorry, conjunction. Conjunction means and. Conjunction means and. See the symbol. Fine. Symbol is like a. Ye. Conjunction. Now negation. Negation. See the symbol. Not. This is the symbol of not. Negation simply negates the statement. Like for true, value become false, and for false, value becomes true. So this was the case of negation. Then see the conditional connective. If P then Q, yani ki P implies Q. P implies Q. See the table? P implies Q. True false is false. True false combination is false. All other are true. Fine. Fine. Now, this is the question. Write down the truth table of. Can you design the truth table? Any one of you? Yes, any one of you?
Yes, ma'am, we will try.
Ma'am.
You can try. But
Yeah.
before designing truth table, you must know the precedence of these operators. See the precedence. This is the precedence. In any statement, first of all, you have to find the negation. You have to find the negation. Is it clear? Because it has got the highest priority. Negation has got the highest priority. Like in mathematics, we were having BODMAS. Here we are having rule of precedence, and the negation is having the highest priority. Fine. Is it clear? Then followed by the conjunction, that is and. Okay. Then in third number, we have disjunction. Disjunction and exclusive disjunction. And exclusive disjunction. They are having similar priority, same priority. And at last, you have to find logical implication and bidirectional implication. Fine. So please write down the order of precedence. Negation is having the highest priority, followed by conjunction, followed by disjunction, and exclusive disjunction having the same order of precedence. And at last, you are having the logical and bidirectional implication. Fine. So now you can proceed. So you have statement P implies Q and P implies Q and negation R, bidirectional R, exclusive disjunction Q. So in which order you are going to proceed? See here. What was your order? Your order was first negation, then and, follows by disjunction and exclusive disjunction, and finally implication and bidirectional. Fine. So let us see what all operators we are having. So first is negation. See here, you are having negation of R. So first of all, you will do this. Okay. In order of priority, after the negation, you are having conjunction. So here you are having conjunction. So second, you will try this. Q and not R. Q and not R. Third one is what? Third one is third priority. You are having this. Fine. Exclusive disjunction. So you will try to find out the value of this. R exclusive disjunction Q. And at last, when you have completed this, there is bidirectional. You will calculate this one, you will calculate this one, and at last you will go for this. Fine. Is it clear? So summary of connectives that you have seen, and is represented like this. This is a symbol of and it is known as conjunction. Second, you are having or. Symbol of or is this, and it is represented as disjunction or inclusive or. Third is your exclusive disjunction. It is represented like this, exclusive or exclusive disjunction. Then you are having not yani ki negation. You can represent it like this, negation of P. Fine. If then is represented like this. Mostly we use this symbol. Fine. It states implication or the conditional statement. And if and only if, it is represented like this by conditional. So these are the list of connectives. Fine. How to represent truth tables? If you are having one variable like P, your variable is P, in truth table, you have to represent like true value and false value, T and F. If you are having two variables, your variables are P and Q. So for Q, true, false, true, false. Okay, under P, true, true, false, false. So in this way, you can have all possible combinations of P and Q. If you are having three variables, fine. P, Q, and R. For R, true, false, true, false, true, false, true, false. Why we are having 8 rows? Why we are having 8 rows? Because our formula is 2 की power 3. 3 means 3 variables. 3 variables matlab P, Q, and R. So 2 की power 3 means 8. So you will be having 8 rows. 1, 2, 3, 4, 5, 6, 7, and 8. 8 rows. So true, false, and so on. Here true, true, false, false, true, true, false, false. And here T, 4 true and 4 false. In this way, you have to represent the truth tables. Fine. Now, coming back to our question. Fine. How will you proceed? You have to form table like this. P, Q, R. How many variables you are having? See the letters, English letters.
True.
One P, English letter P. One is English letter Q, and third one is English letter R. So here you are having 3 variables. So first of all, for truth table, write your variables P, Q, and R. So here you are having precedence. Negation is at the top priority. So see where negation is. Here is the negation. Negation of R. So find the negation of R. Fine. After negation, what is the priority? You are having conjunction. So where is the conjunction? This. And what conjunction is doing? Conjunction is between Q and not R. So once you find the value of not R, you can find conjunction with Q. So here we have written Q conjunction not R. Fine. Then after that you are having what? Disjunction and exclusive disjunction into priority. So here, are you having any such case? Yes. Yes, you are having exclusive disjunction. So you have to calculate this. Fine. Fine. And at last, what is remaining? This implies. Implies were having lowest priority. So you know the value of P. You know the value of this. So you can find this. P implies this. And after finding this, you can find the bidirectional implication. Is it clear, students?
Yes, ma'am.
Is it clear? So what is
Yes,
important?
ma'am.
Important is that you should know the precedence. If you are not knowing precedence, it may happen that your answer will come wrong. So for the precedence, first of all, in any expression given to you, you have to see for the negation. Go for negation first. Go for negation. See where the negation is. Then what? Conjunction. This is your conjunction. Fine. Then here what you are having? You are having disjunction. No. You are having exclusive disjunction. Yes. This. Then in priority you are having this implication. So here you are having implication. Calculate this. You are also having this. So once you have calculated this left hand side, this right hand side, so you can have left hand side bidirectional right hand side in this way. Fine. So how you can proceed? Yes.
From
So,
not or.
yes, you have to start forming the truth table. Just go through it. Do this question. Do this question. I will show you question on the screen. This is a question. Try to find out truth table of P. Note down. P implies Q. P implies Q and not R. Bidirectional R. Exclusive disjunction Q. Just try to form the truth table and tell me the values, what values you finally found. Will you do it, class?
Yes, ma'am.
Yes, ma'am.
Yes, try it. You have to write down the truth table of this. Yes. How will you proceed?
Yes, ma'am.
How will you proceed? Dekho. Those who don't understand, please see here. You are having 3 variables P, Q, R. Fine. Before starting, just write down 3 variables P, Q, R. Fine. Then start with filling the table. Just put true. For true, truth value, put T. For false value, put F. True, false. As you are having 3 variables. Fine. 3 variables. That is P, Q, and R. So how many rows you will be having?
8 rows.
8 rows. यानी कि 2 की power 3 यानी कि 8 rows. ठीक है. So once you have completed this, start here. True, true, false, false, true, true, false, false. For creating all possible combinations of P, Q, and R. After Q, start with T. Fine. 4 T's and 4 F's. Now you are having all possible combinations in 8 rows. Fine. Now you are having all possible combinations in 8 rows. Now what was your next step? Your expression. Where is your question? Okay, your question is like this. This is your question. This is your question. Fine. This was your question. So, and what was your order of priority? You should know the question. You should know the order of priority.
Not
Order of priority
first.
was like this. Not,
Not
fine,
first.
conjunction, disjunction, exclusive disjunction, implies, okay, and bidirectional. Fine. So first of all, look whether your expression is having this symbol of negation. Yes, your expression is having this symbol of negation at R, at variable R. So find negation of R. Negation of R. So where is R? This. So negation of R will be just opposite. R is true, so negation of R will be false. R is false, negation of R will be true. R is true, negation of R false. R false, negation of R true. R true, negation of R false. R false, negation of R true. R true, negation of R false. R false, negation of R true. Fine. Is it clear, class?
Yes.
Is
Yes,
it clear?
ma'am.
So
Yes,
you
ma'am.
have done this. Negation you have done. See whether it is having any conjunction. See, yes. Here you are having conjunction. Conjunction between Q and not R. Q and not R. Just try to find. Yes, class find. Find conjunction. Okay, Q and not R. So you are having Q. You are having Q. You are having Q. And you are having not R. And you have to find Q and not R. You have to find Q and not R. Q and not R. And बीच में क्या है? What you are having? And will be giving you true when both are true only. True, true, true. In true, true, true. When both will be true only, answer will be true. When both will be true, answer will be true only. Otherwise, answer will be false. Yes, have you done it?
Yes, ma'am.
Have you done it, class?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am. Yes, ma'am.
Then you were having this also. This we have missed. This we have missed. है ना? You are having exclusive disjunction also. So just try to find out exclusive disjunction of R and Q. Find exclusive disjunction of R and Q. R and Q. Exclusive disjunction. So R is here. And Q is here. Q is here. R is here. Okay. R exclusive disjunction Q. Just find. Find the values. Are you having same values? R exclusive disjunction Q.
Yes, ma'am.
Yes.
Yes, ma'am, same value.
Yeah. R exclusive disjunction Q.
Yeah, the same value.
Okay. Yes. R exclusive disjunction Q. Fine. Then find P implies Q and not R. Find this. P implies Q and not R. This is your P. Implies Q and not R. This is you. This is Q and not R. And बीच में implies. Just calculate. P implies Q and not R. Yes, are you doing it? Are you performing it?
Yes, ma'am.
Yes, ma'am.
Yes, do it. See, P implies Q. See how P implies Q is done. In this small table, see how P implies Q is done. P implies Q. For true false combination, result is false. For true false combination, result is false. Fine. And see also how bidirectional P and Q is done. See how bidirectional P and Q is done. For any one false, result is false. For any one false, result is false. Okay? Between P and Q, fine. For any one false, for any one variable's value as false, we have result as false. So you should keep in mind this table. This table is very important. This is important when you are finding P implies Q, when you are finding Q implies P, and when you are finding bidirectional P and Q. This table is very important. Fine. You have noted down, class? Yes? Is it clear?
Yes, ma'am.
P implies Q, Q implies P, and P bidirectional Q. If this is clear, then you can perform other operations in this table also. Fine. So we have completed P, Q, R, not R. Q implies not R. R exclusive disjunction Q. Now what we have to perform now? Yes, class. What we have to perform now? Yes, class. We have to perform this. This. Fine. And then finally we will perform this operation. So now we have to perform this. This is P implies, fine, Q and not R. Just try to find out. Q and not R you already having. This is Q and not R. This is, and for P you are having this column. Just try to find out. This is P. Okay. And do you know how the table of this is formed? P implies Q. P implies Q. Okay. In P implies Q, only true false combination will give result as false. Fine. Now try on your own. Just try to find out the result. Anyone can tell me the result? Yes. This is the column P and this is the column Q and not R.
The first one is false.
Yes. Here we are having true, false.
Yeah.
So result will be false.
False.
Here we are having true, true, result will be true. Here we are having true, true, result will be true. Here we are having true. Okay. See in this column. This one is the main column. True, false, result will be false. True, true, result true. True, false, false. True, false, false. False, false, true. Okay, false, true, true. False, false, true. False, false, true. Have you done it, class?
Yes, ma'am.
Have you done it?
Yes, ma'am.
Okay. Okay. Now everything is clear. And final step. What is the final step? What is the final
By
step?
direction.
P.
By direction.
Yes. But you have to find the bidirectional. You have to find the bidirectional. So you are having this. P implies Q and not R, and you are having R exclusive disjunction Q. Now these are the columns. You have to perform operation in these. These are the two columns. You have to perform operation in two green columns, and you have to find the, suppose consider this as L and consider this as M. So you have to find L, find L bidirectional, L bidirectional M. Well, in the simplified way I have written, for complete this I have written L, for complete this I have written M. So you have to find the bidirectional L and M. And what happens in bidirectional? When you calculate bidirectional, yes, what happens? If any one of truth value is false, result is false. If any one of truth value is false, result is false. So we can see here, false value, result is false. True, this value is false, so result can be directly false. Fine. False, false, true. True, false, false. True, true, true. True, true, true. True, false, false. Fine. So in case of false, false also, you are having true. True, true, true. False, true. False. False, false, true. True, false. False. True, true, true. Fine. For a combination of true and false, you are having false. For a combination of true and false, false. Okay. For a combination of true and false, you are having false. For a combination of, this is, first one is false, false. So you are having true. Is it clear? Class? Is it clear?
Yes,
Yes,
ma'am.
ma'am. Clear.
Now let me give you some examples. Fine. P, Q, R. These are the three variables that I'm using. Okay. P bidirectional R. Just find out this value. P bidirectional R. P bidirectional R. P bidirectional R. Just try to find out the value. Yes, class. Create your own table. See, here you are having two variables. Okay? And the variables are P and R. Variables are P and R. So 2 की power 2. You are having 4 rows. 4 rows. So P and R. You will be having 4 rows. True, false. These are the values. True, false. Okay? True, true, false, false. Now what you have to find out? You have to find out bidirectional. P, R. Fine. Just simply find out the value. You know, for bidirectional, if we are having any combination like true false or false true, the result will be false. The result will be false. Otherwise, the result will be true. Is it clear, class?
Yes, ma'am.
Yes,
Is
ma'am.
it clear? Is any problem here?
No problem.
Are you having any problem?
Not
Yes, class. Are you having any problem?
as of now, no, ma'am. It's clear now.
Clear?
Yes.
Okay. Fine. Let me give you another example. Now, let me give you another example. P implies Q. Just find out this. Make your table. Just give me the result. P implies Q. Fast. P implies Q. P implies Q.
Done, ma'am.
Hmm?
It's done. P implies Q.
Yes, P implies Q. True,
True.
false.
True, false, true.
False. Fine. And true, true, false, false. Fine. And P implies Q. It is false only for combination of true and
True,
false.
false.
So here you are having false value. Otherwise, you are having all true values. Okay? Fine. Is it clear?
Yes, ma'am.
Yes, ma'am.
Fine. Is it clear?
Yes, ma'am.
Yes, ma'am. It's not clear.
Okay. P implies Q and R. Just find the truth table of this. P implies Q and R. Do you know the precedence rule? Do you know the precedence?
Yes, ma'am. First,
You should know the precedence.
citation.
Yes. Before calculating it, you should know the precedence. Precedence is negation, conjunction,
Injection
disjunction, exclusive disjunction,
and
Fine.
implication.
implication, and bidirectional. Before performing this. So, here, are you having any negation?
No.
No. So, are you having conjunction?
Yes.
Yes. So, go for conjunction first. Fine. Fine. And how will you draw the table now? Yes. Please
Three
tell me
variables.
how you are going to form the table now.
Our table for three variables.
Yes. Draw the table.
Yeah. P, Q, R.
Draw table. P,
Q, R.
R. Draw table. P,
QR.
Q, R. Fine. Put the values. True, false, true, false. true, false, true, false. We are having three variables. So 2 की power 3 is equal to 8 rows. 8 rows. True, true, false, false, true, true, false, false. Okay, then 4T and 4F. Fine. Now you have to find Q and R. Q and R. Q and R. Is it clear? Class, is it clear?
Yes.
Q
Yes,
and
Yes, ma'am, it's clear.
and
Yes.
and result is true when both are true. Result is true when both are true. For any cases when both the inputs are true, result is true, otherwise it is false. After finding this, what you have to do next? Are you having any conjunction, any disjunction,
no.
No.
exclusive disjunction? No.
Mm.
Then here what you are having? This
Only
logical
this.
implication. So now you know this. You know this. What you have to find? Okay, you have to find P implies Q and R. Where is Q and R? This is Q and R. And where is P? Here you are having P. So just find P implies
False.
Q and R. Is it clear? Take it as A. Just take it as B. So you have to implies A. You have to find A implies B. This is your A. This is your B. Fine. Class, is it clear? This
Yes,
is your
ma'am,
B.
it's clear.
Yes, ma'am, it's clear.
Yes, or this is your A. Just find A implies B and put here the answer. That will be your final answer. Is it clear?
Yes.
Is
Yes,
it
ma'am.
clear? It means for any given expression, first we have to see what is your precedence order, what all operators are given in the question. Fine. What all questions are given, what are the variables present in the question, and what is the order of precedence. Is it clear?
Yes, ma'am.
Okay, fine. Let me give you one more example. P implies not Q and R. Okay, and R or S. Can you do this? Yes.
Yes, ma'am.
Can you do this?
Ma'am.
How
Sure.
will you? How are you going to proceed? What you will look for?
Q naught first.
Yes. What
First,
all are variables?
P, Q, R, and S.
Yes.
4
And
variables.
what is the order of precedence? What is the order of precedence? First is negation.
Negation.
Okay. Second is
And.
conjunction. Third is disjunction or exclusive disjunction. Fourth is logical implication. Yeah, bidirectional. Fine. So what you will do? First of all, you will do negation. Negation. Then after doing negation, you are
Conjunction.
having what? You are having conjunction. You will do this. After conjunction, you are having disjunction. So you will do this. After doing disjunction, you are having this implication. So you will do this implication. Is it clear? Class, is it clear?
Yes, ma'am.
Just do it and
Yes,
find the
ma'am.
truth table. Just find the truth table for the above expression. Truth table for the above expression. Just do it. Have you done it, class? Class, have you done it? P implies negation of Q and R or S. Fine. Now I am giving you one more example. We are having variables G, H. You have to find not G, not H. Fine. G or H, not G, not G. Fine. And not H. Fine. Just try to find this, class. Here, how many variables you are having? How many
4
variables you
variables.
are having? Yes,
2 variables.
2 variables. Just do it. So we will fill the truth values. True, false, true, false. For G also, true, true, false, false. Not G. Not G means here we are having T. So F for T, F. For F we will having T, and for F again T. Not H. Not H. T का F. ठीक है, for F T, for T F, for F T. Now what we are having? G, yes, or H. Anyone can be true. Result will be true. G or S. True, true. True, true, true.
True, false.
Yes. True, false, again true. False, true, again true. And false, false, false. Now, not G and not H. Yes, consider these 2 columns. Consider these 2 columns. Fine. Consider these 2 columns.
Yes,
These 2
ma'am.
columns. Fine.
False, false, true.
Yes.
Only one is false. True.
Yes, not G and not H. See how interesting it is. Not G means means true. Not H means false tha, so it will be true. So true and true will be true. Is it clear? Now fill here. Fill the values over here. But here automatically we have done the negation part. We have kept actual values. So G was T. We
So
have
it will be-
filled. We have calculated not T. The not T is F. So we have written F. H was T. We have calculated not T. So not T is false. We have kept here value as false. Is it clear? So false and a false, our result will be false. Is it clear? We
Yes,
have
ma'am.
kept here calculated values. That is why we have written here not G and not H. Fine.
Yes.
Just find out the values.
The values will be false, 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 and the end one true.
Yes. So done by everyone?
The last one will be true.
Are these done by everyone? Class?
Yes,
Are you having any problem?
No, ma'am, it's clear.
Okay. Let us take one more example. P, Q, not P, not Q, P and Q, not P. Not is also written like this. Not P can be written like this also. Not P. Okay. Not P or not Q. Not P and Q. Fine. Not P and Q. This is, we can write not like this also. This is also true. Not P and Q bidirectional, not P or not Q. Fine. Now find the values. Yes. P, Q, not P, not Q. P and Q, not P or not Q, not P and Q. So not P and Q, bidirectional, not P or not Q. Fine. Is it visible? Yes. Class?
Yes, ma'am.
Yes. Do it. I want the final answer of this. Let me see who is doing it correctly. Yes. How many variables we are having?
2.
2 variables.
Two
Variables
variables.
are P and Q. Fine. So true, false, true, false. Fine. True, true, false, false. Not P. Not P means negation of P. False, false, true, true. And for not Q is false, true, false, true. Now find P and Q. So what is the value of P and Q? Tell me. Yes, tell me P and Q. Yes,
The
class.
last one,
P and
T
Q.
is
T. Answer will be T.
T,
True,
F,
false.
F, F. Just first one will be T, no
F, F,
false.
and
F.
F. Fine. Is
Yes.
it clear? Now tell me answer of not P or not Q.
False,
Not P.
true, true.
Yes. See here. This is not P and this is not Q. And we have to do or yani ki we have to do disjunction. Fine. Yes. Anyone is true, answer will be true. So false, false, false. Yes. False, true. True.
False, true,
True.
True, false.
true, true.
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 And true, true, true. 1 false and 3 true.
Yeah.
Fine. 1 false and 3 true. Now find this.
1
Not
false and 3 true.
P and Q. So P and Q is here.
1
P
false
and
and
Q
3
is
true.
here. Fine. And you have to find not of this. Not of this. So T will become F.
F.
F will
F,
become
yes.
T. F will become
T.
T. F will
T.
become
F.
T. Is
T.
it clear, class?
Yes, ma'am.
Yes, ma'am.
Is it clear? And see the last one. And now the answer will be from your side. This is not P and Q. So not P and Q, I will show you not P and Q. This is the left hand side. Okay, fine. This is the left hand side. Bidirectional. Bidirectional. And here not P or not Q. Not P or not Q. Not P or not Q. Yeah, not P or not Q. Fine. And you have to find the bidirectional. You have to find the bidirectional. Bidirectional. Can you find? Give me the final
Yes,
answer.
ma'am.
Let me see who can do it.
False, true, true, true.
And do you know how bidirectional is calculated?
For any one of the variables false, it
Anyone
will
is false. Result is false.
false.
Not P and Q. Not P and Q. Now you can easily do. Fine. It is easy. You have already done examples. Yes, very good. Now the things are clear, I think.
Yes.
Yes.
Yes, ma'am. Yes,
Is
it's
it easier
clear.
now? Can you perform such examples?
Yes.
Yes, ma'am.
Okay, let me give you few examples. P implies Q and R, P implies Q and R. Find this. Question number second. P and not R implies Q. Find the answers. So first question is having how many variables?
3.
How many
Three
variables are
variables.
there?
3 variables.
3.
1, 2, 3. Fine. And what is the order of precedence? You should remember order of precedence.
Not first.
Yes. Not.
Negation.
Yes.
Not.
Conjunction, disjunction, exclusive disjunction,
Disjunction.
and implication and bidirectional. So you can easily do.
Bidirectional.
So
Yes.
here you are having, here you are not having this, you are having this. Fine. And you are having this operator. Is it clear?
Yes.
Class, is it clear? And
Yes.
what you will do, you in the similar fashion, you will design. Okay? And you will start performing. And the first operation that you can do is conjunction. Fine. See the second example. In second example, you are having how many variables? 3 variables. Fine. Let us see the precedence. Precedence is negation, conjunction, disjunction, exclusive disjunction, okay? Implication, bidirectional. Yes, which operation you will perform first?
Not.
In order of priority? Yes. Are you having
Not
negation?
Negation.
Yes, you are having negation. Fine. Then are you having conjunction? Yes, you are having conjunction. This is your
Yes.
order. Okay? Then you are not having disjunction or exclusive disjunction. And
Exclusive
finally, you are
disjunction we
having,
do not have.
yes, you are having implication.
Implication.
Done? Is it clear?
Yes.
Class, is it clear?
Yes, ma'am.
Okay. Now, P, Q, R, S. Okay. Not P, not Q, a negation of Q. It can be written as not P. Fine. Negation of Q. Negation of R. Fine. Negation of S. Negation of S. Both are same. Both are same way. Then not P or not Q or not R or not S. Or you can find not P or Q or R or S. Fine. Suppose this is your X and suppose this is your Y. Are X and Y same or not? Do the result that will come here and here will be same or different? It will be same, it will be same or different. So how will you go? Firstly, you will create a table with the variables, all possible values. How many variables you are having?
Four
Yes, class. How many
variables,
variables
madam.
you are having?
4
Four
variables.
4 variables. So how many rows you will be having?
16.
Very good.
16
Fine.
rows.
And how will you proceed? In similar
True,
fashion
false, true, false,
and so on. Fine. True, true, false, false.
Yes.
Okay.
True.
Yeah, okay.
And then 8.
Yes.
False.
And then 8 false. And in this way, you will initialize working here. Then you will find negation. Fine. Then ORing, OR operation. Then finally you will find values here. When you are having P or Q or R or S. So you can form a column for P or Q or R or S, and then you can find the negation. Is it clear?
Yes.
Is it clear? And then you can compare whether the results are same or different. Is it clear? So I think propositional logic is clear. What is
Yes, ma'am, it's
proposition?
clear.
What is proposition?
It's a declarative sentence which can be true or false.
Yes. Yes. Exclamation, question mark, and ordering. These are not the propositions.
Proposition.
Is it clear? Somewhere you can also find table appearing like this: P, Q, P and Q. P and Q is written for conjunction. P and Q is written for conjunction. Fine. Somewhere you can find, in some books you can find P or Q. P or Q is written for disjunction. It is written for disjunction. Fine. Is it clear? P implies Q, and P if and only if Q. P if and only if Q. P if and only if Q. That is bidirectional. Bidirectional. It means P implies Q and Q implies P. In this way also you can find the value. Is it clear? P implies Q and Q implies P. Done?
Yes.
Is it clear?
Yes, ma'am.
Is it clear? Done? And regarding the truth table, you will find truth table in this way also, like A, B. Fine. A, B. And for AND operation, Y is equal to A dot B. In this way, it is also represented like this: A, B. And values can be represented like 0, 1, 0, 1. 0 is equal to false, and 1 is equal to true. Fine. This way: 0, 1, 0, 1. Okay, fine. Is it clear? 1, 1, 0, 0. Okay. This is ending. Yani ki this is conjunction. In conjunction, both should be true. Then the result will be true. 0, 0, 0. Is it clear? It is similar to A and B. Fine. Is it clear?
Yes.
Yes,
Is
ma'am.
it clear? This is for AND, or this is for conjunction. In some books you can find table like this. Okay. Then or disjunction. The truth table can be created like this also. Inputs are A and B, and output is equal to A plus B. यानी कि or operation or disjunction. Fine. 0, 1, 0, 1, 0, 0, 0, 1, 1. Fine. If any one is true, result will be true. If any one is true, result will be true. Otherwise, result will be false. False is represented as 0 and truth is represented as 1. Fine. Is it clear? Class, is it clear? Is it clear?
Yes, ma'am.
Yes, ma'am. Yes.
Fine. In this way, you can find the tables. Then XOR, यानी कि exclusive disjunction, or we can also say exclusive or. And here the truth table can be like this. In one side we will be having inputs In another side, we will be having output. A and B are input variables. Y is equal to A XOR B. A XOR B, exclusive or exclusive disjunction. We are having two variables, so we will be having 4 rows: 0 1 0 1 0 0 1 1. Fine. For any variable that is 1, the result will be 1. Otherwise, it will be 0. Is it clear? For 0 0, result is 0. For 1 1, result is 0. Fine. This is your exclusive or exclusive disjunction. Is it clear? Is it clear?
Yes, ma'am.
Class? Yes. Is it clear? Fine.
Yes,
And
ma'am.
now you were having A dot B. A dot B. And अगर and को हम negation कर दें, if and is negated, we will have NAND. अगर and को हम negate कर दें, negate इसका negation कर दें, this symbol is for negation. तो अगर हम इसको negation कर दें, तो it will be represented like this. ये तो हो गया A dot B. और अगर हम A dot B का negation कर दें, तो ये 0 हो जाएगा 1. This 1 will be 0. This 0 will be 1 and this 0 will be 1. Fine. तो जो आपने करा था उसका उल्टा हो जाएगा. जैसे मैं एक एग्जांपल में आपको एक्सप्लेन करती हूँ. एक एग्जांपल ले लेते हैं. सपोज हमारे पास जो इनपुट्स हैं, सपोज वी आर हैविंग इनपुट्स A एंड B. फाइन. 0 1 0 1. ये हमारे पास इनपुट्स हैं बिकॉज वी आर हैविंग टू वेरिएबल्स. 0 कॉम्बिनेशन है ये. दिस इज द कॉम्बिनेशन and we have to find the output. Yes. So what will be A dot B? Y is equal to A dot B. A dot B means what we are finding? We are finding
A and B.
Yes, A and B. ठीक है. तो ऑपरेशन क्या है? ये we are finding and ऑपरेशन को आप पहचान सकते हैं. You can identify it. It looks like A. You can say it as and or dot. ठीक है. And here the result will be 1 when both are 1. In rest of the cases you are having result as 0. Is it clear? Now you want to find negation of A dot B. Fine. So negation of A dot B is written as bar. A dot B का complete bar. A dot B complete bar. Fine. So here we are having values. Fine. So 0 will become 1. 0 will become 1. 0 will become 1. And 1 will become 0. Is it clear? And it was known as and here it is known as and. Not of and यानी कि NAND. NAND. Not of and यानी कि NAND. NAND. NAND operation. Is it clear? Class, is it clear?
Yes.
Class?
Yes,
Yes,
ma'am.
yes, ma'am, it's clear.
Is it clear?
Yes, ma'am.
Is it clear?
Yes.
Okay.
Yes, ma'am. Yes.
Now find P, Q. Fine. Not of P and Q. How will you find it? Not of P and Q. Not of P and Q. Yes, how will you find? मतलब not is same as this. Both are same. ठीक है. Negation or not. Both are same. Here you are having bracket. Na? First you will find what? First you will find P and Q. because the negation, you have to find the negation of this whole term. So you should know what this term actually is. Then only you will be able to find the negation. So you have to complete this term, and finding this term, after finding this term, you can find the negation. Because negation is not on P, negation is not on Q, negation is on P and Q. Is it clear, class? Is it
Yes.
clear?
Yes, ma'am. Yes, ma'am.
Class, is it clear?
Yes, ma'am, it's
Yes,
clear.
ma'am.
Negation is not on P, negation is not on Q, negation is on P and Q. Negation is on P and Q. Is it clear?
Yes,
Yes.
ma'am.
Now find, I'm giving you some questions. Please try to do these questions. First, please note down P or not P. Can you find it? P or not P? How will you do it? P, not P. And then you will find P or not P. Is it clear?
Yeah.
Will you do this?
Yes, ma'am.
Okay. Then next. Next. Not P and not P. What you will do first? You will find this, not P. Fine. Then you will find this, and then you will do this. Is it clear? Class, is it clear? Not P. You will find
Yes,
the
ma'am.
not P. You will perform P and not P, and negation of P and not P. Is it clear, class?
Yes,
ma'am.
ma'am. It's clear.
Okay. Then third question. Third question is P and Q and P. You have to find this. P and Q. Fine. Logical implication P. How many variables you are having?
2.
Yes?
True.
Two
Two
variables.
variables.
P and Q. Fine. True, false, true, false. You can also write 1, 0, 1, 0. In some books, you will find it as 1, 0, 1, 0, 1, 0, like, and 1 is equal to true and 0 is equivalent to false. Fine. True, true, false, false. Fine. Then you have to find P and Q. P and Q. And then P and Q implies P. Is it clear? Can you find it? Can you do it?
Yes, ma'am. Yes, ma'am.
Next.
Yes.
Q implies P or Q. And next is P implies P or Q. Fine. Question 4, question 5. Q implies P or Q. P implies P or Q. You have to find these. Fine. Are you able to do this? The next question. Question number 6. P implies P or Q. Q implies P or Q. P and Q bidirectional. Q and P. P or Q bidirectional. Q or P. So these are very simple questions. Question number 8 and question number 9. So these are very simple questions. Again, PQ 2 variables. It is again case of 2 variables. 2 variables again case of 2 variables. Is it clear? Yes. Will you be able to
Yes,
perform
ma'am.
these questions?
Yeah, we can.
Yes. Question number 10. P or V. P or P. P or P. Bidirectional P. Can you find the output of this question? It implies P. You have to prove. Is it correct? Is it correct? Suppose this is our left hand side, right? This is our left hand side, and this is our right hand side. Can you prove left hand side is equal to right hand side? How many variables are we having?
One variable.
One variable p. Its value will be true and false. ठीक है? p. अब आप ये देखिए, just see p और p. तो true or true, true, false or false. Right? So result will be true, true or true. Result will be true, false or false. Result will be false. Fine. So what will be the result of P or P? Yes. P, disjunction P, what will be the result? Yes.
True, false,
True or true, true.
Yes,
False or
true.
false? False.
false.
Is it clear? Fine. So
Yes.
this is our left hand side. See what is right hand side? Right hand side is P. P was TF. So it means left hand side is equal to right hand. In this way you have to prove. Fine. Fine.
Yes, ma'am. Yes, ma'am, it's clear.
Nabi
So now
Aurora,
you
my
have any
one
questions to do? Now ask me any question. Please feel free to ask me any question. Any query? Let us move to the start of the session. What we have covered today. We have started with subject discrete mathematics, MCS212. Fine. In discrete mathematics, we are having 4 blocks. Today we have started with the block elementary logic, and here we have started unit 1, propositional calculus. Fine. Under propositional calculus, we have done what is proposition. Fine. What is proposition? Truth value. How proposition are defined. Examples of proposition. How we can differentiate whether the given statement is proposition or not. Few examples. Is the screen visible?
Yes, ma'am. It's
Class?
Yes, ma'am. Yes.
Okay.
Yes.
Few examples of propositions. Fine. Disjunction.
Mhm.
Then truth table for disjunction. Then different operations like exclusive disjunction. Conjunction. Truth table for conjunction with some examples. Negation. Fine. Different connectives like if P then Q, like P implies Q, or P is sufficient for Q, or P if Q. That is conditional implication, or the conditional statement, or the conditional proposition. Fine. Then there are truth tables. Converse. Again truth table with some examples. Then biconditional. Fine. Their truth table. Then rules of precedence. Highest priorities for negation, followed by conjunction, disjunction, exclusive disjunction, logical connectives, bidirectional, their symbols, their statement examples. We have seen the method how to represent the truth table for 1 variable, 2 variable, and 3 variable cases. We have defined several truth tables for them with step-by-step example of how to proceed for creation of truth table for any given expression. Fine. These were few examples that we have seen. Different cases, different ways how to represent the conjunction, disjunction, how we can obtain NAND from AND by negation, and at last I have provided you some examples to solve. Fine, class? I think this is enough
Yes,
for today.
ma'am.
yes, ma'am.
Okay,
It's
fine.
Okay.
thank you.
Have you
Madam,
understood?
yes, ma'am. Please
Have you
share
understood?
the notes we repeat.
Okay, I will share. Fine. Have you understood?
Okay.
Yes, ma'am.
Yes, we
Any
understand.
problem?
Just share the notes we repeat.
No, ma'am.
Practice it.
Fine.
We have understood.
Okay. So we can leave now. Fine.
Thank you, ma'am.
Okay. All the best.
Thank you, ma'am.
Okay. You may leave.